Okay, so we're into 10.6, so 2 new points. 1, the person was Gay-Lussac. 2, the answer is that we're only going to use one step, or they said only use step 2. Or I'd even take the problems are 1 step long, something like that. You're only going to need to use the coefficients, that would work. Next time when we do a 10.7 quiz, the 10.7 quiz is going to have 4 new points. 10.7 also is the end of the chapter, so you read a box about chromium and tell 2 things about that. And then the rest of the quiz is just going to say the same for what all this stuff is I'm saying. Except, instead of number 2, I'll ask you to just state the law. So the law is pretty long, so I make it worth 2 points. So the law says whenever gases react, their volumes are in small whole number ratios if they're measured at the same temperature and pressure. So I'll hit that up again. I'll make that all worth 2 points because there's a lot of stuff there. So when gases react, I guess could be a half, their volumes, half-ish maybe, are in small whole number ratios, another half-ish or so there, and they have to be measured at the same temperature and pressure. And the rest of these are all the same words that we've had day after day after day. So stoichiometry is the measurement of the relative quantities of chemical reactants and products in a chemical reaction. The 5 things is reactants and products, molecules of each, moles of each, relative masses of each, and today's big deal is the volume of gases comes straight from the equations, coefficients. 10 is the mole method. 11, the 3 steps are find the moles of known, find the moles of unknown, and then find the mass or volume of the unknown. The thing you have to, the other 3 types of problems is mass, volume, and volume. Before you begin the problems, you have to balance the equations as we've had other days. Limiting reagent is a reactant that is used up. Excess is reactant not completely used up. Theoretical yield is the amount of product you expect. Actual is the amount of product you obtain. The one that's less is actual, and I'd hunt all 4 things today. If you missed 1 or 2 things, I'll go half. But it would be side reactions, isolation, purification, and transferring from container to container. 24% yield is actual, divides theoretical times 100. 25 is the number, 22.4 liters. If you just have 22.4, I'll take it, but I'd really rather have the liters. 26, 0 degrees Celsius is a half, 760 millimeters of mercury is the other half, and that's where we are on 10.6. Again, 10.7 quiz have 4 new points, a box about chromium, and then you'll need the guy's name and then to say the law for 2 points worth of that. Homework we work off of this is 31 to 36. This should be the easiest homework of the homeworks we've had this chapter because like I already said, we can just use the coefficients from the equation is the only dimensional analysis step that you're going to need. So if you want to join me, there's examples starting on page 263. There's an example 1014, so I'll start with that one. So the example 1014 is saying, they give you an equation, they have it balanced, they tell you everything in the question is a gas. And then they're going to ask this time a triple question. I don't know that the homework always asks you triple questions, but this one they did. They tell you there's 1.5 liters of C2H6, and then they ask you to find all of the volumes of all of the other gases. So there's going to be 3 of those. So we want to exchange C2H6 for O2, because that's in there. We could exchange C2H6 for CO2, because that's in there. We could exchange C2H6 for H2O, which even though that's normally a water, that can also be a gas whenever it's steam. And again, all we're going to have to do for liter to liter conversions is just use the coefficients. That's the thing we've said on the quiz every day. The equation tells us the volume of gases. So C2H6's numbers is just going to be 2's everywhere. The O2 number is 7. CO2 number is 4. H2O number is 6. And then just push some buttons. This is essentially multiplying by 3. So that would be 4.50 liters for H2O. This is basically just causing a multiply by 2. So 1.5 times 2, that's 3.00 liters of the CO2. That's multiplying by 3.5, so that's causing a little bit more problem maybe. You need a calculator for that. Or 5.25 liters O2 off of this. This one, I'd probably rather see the dimensional analysis. I don't know how many people I trust to like figure that out. But if you're making this jump, there's just twice as much. So like if you see the C2H6 coefficient and you see this coefficient is twice as much, and you just take this times 2, I'm not going to complain about that. If you look at making this move from 2 of these to 6 of those, and you just realize it's triple, and you take the number and you triple it, I'm not going to complain about that. From 2 to 7, I don't know, maybe you want the comfort of the dimensional analysis, maybe you don't. Some of you have more math, common sense than others. Case by case that, I guess. But that's one of the kind of problems you're going to have is stuff that it's just going liters to liters, and they might ask you for more than one answer because those really aren't so bad. There's also going to be a couple limiting reagent problems, which again, you would know you have those because they're giving you 2 amounts. Not to be confused with those where they ask you for 3 things, something that are giving you 2 amounts. So I'm working up a page 264, example 1015, gives you an equation, it's balanced, everything's a gas. These equations, you can only do this stuff with gases. So the shortcutty problem, it's got to be gas-based. But they're going to tell us, in this question, they tell you, you have 60 liters of the CO, you have 80 liters of the H2, and you're trying to figure out what do you get. So liters of CO, we're going to try to figure out liters of this and just use the coefficients. CO and that, they're both 1s, so this is turning out 60 liters. For the H2, to turn that into CH3OH, the coefficient on the H2 is a 2, and that one's a 1. So we math that up, that will be 40 liters. Unlike the other limiting reagent problems where we were going to have to finish one of them, we don't have to do that this time. We just have to pick one of them. So same way we've decided other days. This one is lower, so that is the limiting question. And that is the answer. We have 40 liters of the CH3OH as an answer caused by the limiting. Hydrogen was limiting, so carbon monoxide had to be the excess. They are going to ask you what's left over. And so this is the point already where I say, like, we did 80% of the work. All the other days we worked for like 10 minutes to get there. We worked here for like 1 minute, and like 80% of the work is done. But to finish, it's the same finish. Just instead of moles of limiting, we're going to go liters of limiting. So the liters of limiting, we would use the 80. We'll convert that from liters of limiting into liters of excess. So the limiting number was 2. The excess number is 1. That tells us there's 40 liters of the excess that got used up. I didn't circle it, I didn't have to, it was already at the beginning. These would be the equivalent of like our circled numbers. The 60 liters of excess that we started with, we used 40, so we're left with 20 liters of excess. And they didn't ask this time for any kind of percentage, so we're done. Homework that builds off of that stuff, again, it goes from, set my paper down, where to put it, here it is. It goes from 31 to 36. So the 31 to 36, 31 to 34 are more like the first column of things that I did. 35, 36 are more like this problem, that those are 2 limiting reagent problems. That's all we've got. See you next time.